g of x equals x plus 2 over x. And then we're going to compare the result by differentiating it in a slightly different way. So first, we need to figure out what the inverse of x plus 2 over x is. I'm going to save you the college algebra work, okay, but hopefully you're good with these, and show you, go ahead and tell you that f of x is equal to 2 over x minus 1. That is the inverse of that g of x function. Okay? Now, the derivative, I'm actually working from the inside out here. Okay? That's my inverse. Now I'm going to take the derivative of that. Okay, I'm going to use our power rule, and it is going to be negative 2 over x minus 1 squared. All right, that is f prime of x. Actually, let's see if we can squeeze it in a little better. Okay, negative 2 there. So this means that f prime of g of x is equal to negative 2 over, instead of an x, we're going to have x plus 2 over x minus 1 squared, which is equal to negative x squared over 2. So that is the derivative of the inverse. So we actually take the inverse function, take its derivative, and then compose that with the original function, and then simplify it. And that is our answer. That is what we were after, the derivative of that. Now, if I were to take the derivative of that function directly, I get the exact same thing. Oh, I skipped a step. I didn't do 1 over that. I apologize. So I need 1 over that function. 1 over that function. F prime of g of x. So my function is negative 2 over x squared. And that is the derivative of my inverse. F prime of g inverse. Oh, let me write that differently. F inverse prime. So g inverse prime. Okay, taking out my x. There's my answer. Example 2, use the inverse function theorem to find the derivative of this function. Now, recall that the cube root is equal to x to the 1/3, just by definition. Alright, so the inverse of that function, okay, I'm going to go ahead and call it f of x. The inverse of that function is x cubed. The derivative of that function is 3x squared. Now we're going to take f prime of g of x. Compose our x to the 1/3, so that would be 3x to the 1/3 squared, which is 3x to the 2/3. Alright, and then the derivative of g, which is the 1 over, so g prime of x is 1 over 3x to the 2/3. Now, if we were to apply the power rule to this and just say, oh, find g prime, that would be 1/3 x to the negative 2/3, which is equivalent to that. Now, the great thing about this process, and I just realized that I did not need that inverse there because we were given the original function, is that this allows us to see what's actually going on later with some other more complicated inverse functions. So let's look at example 3. Find the equation of the line tangent to the graph y equals x to the 2/3 at x equals 8. All right, now I'm not going to use the inverse function theorem for this. Okay, I'm just going to go straight to it. Actually, let's call this, our slope is the derivative of y evaluated at x equals 8. Now our power rule is what I'm going to use. That'll be 2/3 x to the negative 1/3. I'm going to evaluate that at x equals 8, which would be 1/3. That is my slope. Alright, now I actually need a point here. This is my point A. Now I need f of A. That's going to be 8 to the 2/3, which is equal to 4. So we have the function y minus f of A equals f prime of A times x minus A. That is, again, the calculus version of the point slope formula. So y minus 4, and then our derivative was 1/3 x minus 8. So distributing that 1/3, y, we don't want to do that yet, y minus 4, 1/3 x minus 8/3, and then adding 4 to both sides, y equals 1/3 x plus 4/3.